On this particular part, what would you like us to help you program it or demonstrate here in today's meeting?
That's around part.
So just as a little bit of background, we worked on this project last year. We were using Power Mill to mill multiple surfaces. And for this part of the project specifically, we're doing Swarf cutting.
Okay.
So we'd be interested on like understanding how this same process would work in Rhino Cam. So
Okay.
block and we're basically doing Swarf cutting on each of these surfaces.
Okay. So would you like me to show you how to do a swarf cutting on these the side walls in here, the wall surfaces?
And the central one, like the yellowish, that one, that would be the primary surface.
Okay. Would you like to do a swarf cut on this one too, or would you want to do like a surface parallel machining where the tool remains normal to the surface?
We'd like to cut with the length of the tool.
Okay.
We'd like it to be a one single procedure.
Okay.
Process.
All right. Okay. So there's 5-axis methods. You can find it under the RhinoCam premium configuration. So you'll see under the program tab you have 2, 3, 4, and also 5-axis. So you have access to all of the simultaneous 5-axis methods over here. So typically what we do here is before we generate a toolpath, we go through the machine setup in here. So we want to determine what type of 5-axis machine configuration it is. So we go into 5-axis and a number of axes. And then this gives you the option to specify the machine configuration where the rotation axis is both on the head, like we pick head, like if you have a C and a B or A and a B, if the rotation is on the spindle itself, where the part remains stationary on the machine, and then you would pick configuration head, or it could be a combination of a rotary table and a rotary head, or we could be like a trunnion type of machine, which could be table. So you make the determination here. Now, based on what I see here, the part, to me, it looks like your machine is a head configuration where both the rotations are on the head.
Yes, that's correct, yeah.
Okay. Now, your machine can handle computation of the gauge length at the control level, so you can basically just clear this checkbox in here, and you put the gauge length as 0 over here if you're doing like what is called a TCP on, or if its controller does like a G48.1 or G48S1. Each controller has its own way of handling it, so you don't have to double compensate here, so you can put the gauge length as 0. If your control is not compensating for a gauge length, then you need to put in the distance from the pivot point to the spindle face under gauge length, and then the tool length is defined as you create the tools. Okay. So I'm going to leave it as 0. We can change it at any time and then regenerate the operations. Now the next thing we want to do is we want to define our primary axis and the secondary axis. The primary is the rotation of, could be typically like a C axis, which rotates about parallel to the Z. You can pick the primary axis, and then the secondary axis could be rotating about the X or the Y, depending on how your machine is set up in here. So that could be your A or the B, and you can specify rotary axis limits as well, where you can specify limit for the secondary, or you can even say user defined. And for example, I could say the secondary can go maybe like -100 or 110 to +110, depending on how your limits are established for the machine. So you can look up your control, and you can see based on what they set for the limits. The primary also, you can set a limit like 0 to 360, or if there aren't any cables or anything in the way, then most machines can go like no limit, which is plus or minus infinite. So if you actually go to the help system in here, there is an example of like a example of a 5-axis head you can see here. So this is what I was talking about, a C axis, and then could be a B or an A axis for the secondary. Okay?
Yeah.
All right. So I'm going to use these numbers. Does your limits look correct, or is it close enough for the purpose of our discussion today?
I think that should work for today.
Okay. All right. Okay. So once you define the machine tool, the next step is to basically make a selection for your post processor in here. This can be done even before you post process the output to the machine. We've developed posts for several different 5-axis machines, and each machine would be like customized for post. Like for example, here we have different Fager controllers. Are you using a Fager control, or what is it that?
We're using the I believe it's the 8065.
Okay, is it a DMS 8065 that you're using, Fager?
Yeah, yes, it is.
Okay, and the post can be edited and tweaked around here, so we can customize the post. So if you take a look here, in this particular case, we are calling out a G48S1, which is their basically the tool comp on for the gauge length. So the S1 basically activates it, and then S0 basically cancels it out right here. So you can see a G48S0 in the program end. And all of this can be customized. And in this particular post, I believe it said the primary is defined as C and then the secondary is defined as B axis, but we can always, swap that out if it's an A or a B or, whatever the axis codes are.
Yeah, okay.
And we will help you with the post customization. And if you want an extension to be NC, TAP, or .pim, or whatever is the preferred extension, you can set it up right in here. Okay?
Yeah.
All right. So the next step is to build your stock. So if if it's already roughed down to this closed net shape of the part itself, then you can define a stock from selection in RhinoCam, where you can actually model your stock or build it in Rhino, and then you can just select the solid model and do a stock by selection.
Mm-hmm. Yep.
So if you're starting out with a block of material, then you would basically define like a box or a part box stock, and you would basically go through the process of creating your roughing operations. That could be like an indexed operation for roughing. We could do like a 3+2 roughing operation using 3-axis roughing techniques, and then you can go back and do a finishing or pre-finishing using the continuous 5-axis methods. You can do a combination of both indexed and continuous operations with these. Okay. Now, if you want me to build a custom stock in here, maybe we can take some of these surfaces in Rhino, do an offset surface, convert it to like a solid model to do it. So that will give you a stock. If I try to pick these surfaces in here and try to do a stock from selection, it might not work because it's not a watertight model. You can see there's no solid model found in here. So that's the reason why it's not letting us do a stock by selection. But you can model it, and that's the nice thing about working within Rhino.
Okay. Yeah.
Okay. So
let's say that we already approximated it to like 1/4 inch of where it is, and then
yeah. So we need to model something in Rhino to be able to define a stock by selection. I just used a part box stock in here for our discussion here, but I really don't have to define a stock for just programming toolpaths. I can just do a delete stock and just work with it.
We're mostly just interested in kind of like doing the swarfing.
Okay.
We've already roughed it and we don't need to do that.
Okay, so we'll go into 5-axis and we can do a swarf machining.
Yeah.
And now we pick the wall surfaces, and then we can do a floor surface or a floor curve. So I could do a surface selection in here, curve selection. I could say select the curve. I can pick this curve edge, the surface edge right there. So you can see we are using Rhino selection tools. And I can select this as the wall surface in here. So basically you select your surface. And you check the surface normal direction. And then you can pick your curve selection. So we display the surface normal direction based on what you have in Rhino for the surface select. And if you want to flip the normal direction, you can always flip it in here. And then you make a selection for your tool. You can have your library of tools loaded. You can pick the tool that's most ideal for this process. You can pick an end mill, a ball mill, a corner radius tool, or even like a taper tool, depending on what type of tool you'd like to select.
Great. The tool that we were using for that was a 10-inch long bit with a 1-inch diameter.
Okay. Okay, so I'll do a 1-inch here, and then the tool length I'll put in 10. I'll update the tool diameter to 1 inch. I'll just put in a holder diameter of 1.25 inches.
Holder length is actually 10 inches on the tool.
Oh, flute length was 10. Okay.
Yeah. Excuse me.
So
yeah, I'll just...
yeah, 12.
Okay, so I'll do a save as new tool. Automatically update the tool number here. So we have a 1-inch flat mill defined. You can set your feeds and speeds. You can also load them from the tool. The clearance, there's different ways we can define it in 5-axis. So you could do a planar clearance, or you could do a cylinder clearance, depending on what your cylinder axis is defined about. You can establish that. So you can do, if you want to do a cylinder clearance, you can put that in there. And you can specify a radius for it also. You can change the radius, or you can just do a planar clearance as well.
Just question. So also in the folder that we sent you, there was an MTD file. I don't know if that works with RhinoCam the same way, but it's a file that we would pull into PowerMill that is it's a model, effectively a working model of the spindle head that we're using. So when we run simulations, we can actually visualize the specific head that we're using.
So we do not read an MTD file. So what we do is, let me go back in here. So in the machine tool setup, we have machine definition. We have an option to do load from file. And there is a machines folder in the install directory. You'll probably see it even in your copy of RhinoCam. So if you go into the machines folder, there's already a pre-built list of machines, but we can add additional machine tools in here. So for example, if you consider one of these 5-axis routers in here, you need an XML file which establishes all the kinematics. You can open with like a text editor, like a notepad. So it basically has the mapping of the machines, like the head and stuff like that. And then an STL file that represents each of these X, Y, Z, and then the rotational axis. So if I pick one of these in here, let's say I want to just grab this one, that would be a closest one to what you have. You can actually see that it'll display the machine tool and over there. But you need to have a stock to be able to run a simulation with the machine tool. This just basically shows you with the machine tool on during the simulation, but it doesn't check any collisions or interference with the machine itself. It just helps you in visualizing the orientation of the tool when you run like a simulation.
Right, but if we had a stock model, if we were using a stock, it would.
Absolutely, we can write shows the cut material during the simulation. Yes.
It'll detect collisions if it's sort of like gouging the part. Correct?
It'll do the collision with the holder and the shank with the stock, and it'll also identify and mark those in the toolpaths as well. It'll notify you about a holder collision or a shank collision. It's not going to check for collisions, of the spindle with the machine tool or So. All right, so there's an option we can help you add that into the library. So we just need you to provide us these like different, like models. If you have a machine model of your machine tool, you can separate them out to the primary axis, secondary axis, and here I can see, I can use these controls, and here I can show you how I can, just sort of set up rotations in here. So during the simulation, it'll show that to you as well.
Great, thank you.
Okay, all right, so I forgot to mention the orientation and location of the origin. So I thought you already had it placed where you wanted. So that would be your XYZ origin for machining. Is that correct?
Yeah.
Okay, so I have not changed it. So basically all your toolpaths will be computed and output based off this as your 000 location. Okay?
Yeah.
All right, so I had just defined the wall surface, the floor curve for Swarf machining. In the cutting parameters, I can set like the tolerance, the angle change, the distance change. So depending on how big or how small the part is, the larger the number, it's going to have fewer number of go-to motions, which in turn also makes it, the smaller the number makes it your toolpath much more accurate in here. And you can specify by determining how many cuts you want to have for the Swarf. I can just say, just for example, we could just say one cut and generate it. It's just going to produce one cut in here, and because of the tool that we're using, here you can see it seems some sort of like a variation like in the toolpath that you're noticing right there. You see that?
Yeah.
So we need to look at the surface, what the surface is, and maybe you may have to rebuild the surface or untrim it, and you can see the UV points in here. You can probably take a look and see if there's any deviation or anything that's in the surface that could be causing it. You can basically go back and resolve that issue in Rhino to do it. So you can also go back in here and change some of these parameters in here. And you can say, do not perform like a gouge check. You can change some of these parameters in here, determine the number of cuts. You can, then go back and generate it. So this will probably produce more number of passes in here. And it's not able to go here. It's skipping those because it's not able to produce a toolpath. And there's some sort of a surface trimming issue that's it's seeing here. So probably if I export this out as a, and I trim surface and then bring it back in, we might get a better result in here. So for example, if I just go out here and do an export of this, I'll just put it in the same folder right here.
Question, can you ignore surfaces?
Yeah, you would have to basically select the surface that you're machining
Yeah.
So if you basically do not want to machine it, you can split a surface in Rhino and then just do one part of it. So whatever surface that you select, that's what basically you're picking surfaces, individual surfaces that you drive surfaces from machining. So here, all I did was I exported this particular one as a surface. So maybe I need to change the units in here because we want to export in inches. So sometimes if you had an issue with the surface, you bring it in, you might be able to solve it by just, converting it to a trim surface. So let me go ahead and hide this or lock this in here. And then I'm going to go back and re-import it. And I'll just go into the folder where we started out with here. I'm going to go back and open this here. So you see now the surface is much more smoother, nicer here. We can use that, and then I can go back in here. And if you also want to do an edge creation, you can create a duplicate edge in Rhino and generate a sketch or curve from the edge. And now I can go back in here and just reselect the surface and repick the curve and generate the path. So you'll notice that if there were any issues with the surface, now you can see it's a lot smoother, right? So yeah, I just converted it to a trim surface 144 inches. And I can go back in here and change, say I want to do it in basically, let's say 5 passes. And each pass I can say give it like maybe 2-inch distance, step over distance. So it'll just give it in a few passes right there. So you have the ability to control it here. You can change the parameters. And now I can run a verification with just the, I didn't define a stock in here, so I'm just going to do like a animation of the path. And you can see the cutter stays parallel to that surface.
Yeah.
That's your Swarf. So it's basically transferring out. So I'm just showing you the animation in here. I can even speed it up. I can just increase this distance in here. And you can actually see the angles right in the cutter location. We call it the CL file. So that shows your angles in here, primary and the secondary. That's where it's starting. That's your XYZ, and then your primary axis, and then the secondary axis. And if there's crossing the limits, or it'll mark those in here during the in the toolpath itself. So now when I do a post, I'll just put it onto my desktop here. And there's your posted output file, and all of these can be changed in the post. Like these are the program startup codes. You can initially the TCP is canceled, and then you're activating it right here, S1, and then there's your C and the B axis. So if there is an issue with the surface, you can go back in Rhino. Rhino gives you a lot of control for surface editing and trimming, and you can go back and fix it or update it. Any questions?
Yeah, so let's say that you have two surfaces that are, you want to do a swarf cut across two different surfaces that are not joined together. Does it have to be one unique surface in order to do the swarf cutting, or can you?
You can pick multiple if they're, if they're, they have a common edge, or you just basically break them into 2 operations, and we even do the transition from one to the other. So for example, I do a copy of this operation, just do a copy paste, and all I'm going to do is remove these 2 in here and say select the surface. I'll pick this as my surface.
Yeah.
And then I can do either a floor curve or a floor surface in here. So I can say, surface, floor surface. I can pick this one. And I can check the normals for both of them, make sure they're in the correct direction. You can say number of passes, say 1, and that'll get you a Swarf. So you can also have it go to like a tool change point before the rotation of the head. For example, depending on what this point is, if I do analyze a point in Rhino here, so that one is about 19 inches up in the Z, right? So for example, I could say 25 right here, and then if I regenerate these path here, So the next one I regenerate, it'll create a transition. If you will, it'll go to that point, perform the rotation, and come down. So it'll make sure that you're clear of the work envelope when you want to do a transition, for example, right?
Right.
So it shows the motion. If I run a simulation here, it shows that the cutter is going over there from the previous location, and then it's changing, orienting the head, and then it's going to go down. So you don't want it to do a transition rotation while you're within the material, or while you're just in the clearance plane. You want it to go to a safe location. So you can establish this tool change point. Now, if you do not put in a tool change point, it'll assume that it's going to use the clearance height in here. So when I do that and then regenerate the path, it's considering that you're using the clearance height, which is safe enough, but you can always change your clearance height in here for each operation. And you could say, instead of automatic, I could say part max plus maybe 10 inches for the clearance.
So it doesn't have to go all the way back towards the origin. Like you can just
Right. This one, in this case, I put in the clearance to be 10 inches above the part. You can see it's going up right there from the previous operation where it ended. So this is where the cutter is going to be. So it's basically, that's where it ended right there. You can increase the clearance height on that one too. So I can go back and change the clearance height on this. I can go to clearance and put in part max plus 8 inches, for example. So that moves the clearance height 8 inches above right here, and then you'll see that's where the tool leaves the material, right? And then from there, it transitions over to the next starting location, which should be over here. And you can actually see all of these coordinate values right in here, even before you post-process the code.
Mm-hmm. Yeah, that's lovely.
And I can post both the operations into one output file. So when you're programming, it could be 2 operations. But when you post it out, you see the first operation in here. So the next operation, you can see it goes from right here into the next starting location. And then saving your file in Rhino, I could do a save or just do an incremental save. So it automatically saves all of your CAM data within the same part. I repeat the same process for the other side, copy, paste, just, pick the surface, wall surface, check the normals. That's typically I do, make sure it's in the right direction. Select the floor surface, generate it. So that's going to get you a toolpath for the other side. So that's how you go about programming it. Any questions? So you can see there's some issue with the surface in here. You can see the toolpath is not what you would expect. So either if you look at the surface in here, maybe it could be an issue with the trimming or the way it is. So what I would typically do is, I can go ahead and just take these two, just convert it into a trim surface and then bring it back in, and that'll solve the issue, like what we did for the top surface here, right? Or sometimes, instead of a floor surface, a floor curve might give you a better result. So you have these controls to play with it in RhinoCam.
So for Swarf coding, it still reads the ISO curves, correct?
Yes, yes.
So the surface should be modeled based on the...
Yeah, if you have a rule surface, then, it works better for you, right?
Right, okay.
And then anytime you want to delete an operation, suppress it, right click and cut, you can suppress or delete. Cut will delete an operation. So very similar to how you work in your 3-axis. So the goal here is the ease of use. It's not too cumbersome, too hard to work with. And if you wanted to cut slightly below on this particular one, if you wanted to good tool to go past it in here, if this is just like a support and you wanted to cut past it, you can always use what is called a distance to compute, like a tooltip clearance. I could say maybe -1/4 inch. So it's actually going to push the tool down by that amount if you just pick the floor curve. Or if you wanted to go below this, you could even put in a tool with a negative axial offset. I can say -0.5. I'm going to call this tool with an offset of 2, offset of -0.5. So I'm going to save this as a new tool. Now what this is going to do is, if I pick this tool in here and generate the path, it's actually going to push the cutter down by that amount. You see that? It's axially offsetting the toolpath. So if you had a trim that you're trying to cut and you want to go past it, then you can basically, have it put the cutter below that by that amount.
Right.
So you got all these controls in here as well.
Can you edit a toolpath once it's been calculated?
Can you edit a toolpath? Yeah, you can double click on the folder and go back and make changes in here. You can edit any of the parameters. Let's say you want to change your entry and exit. I could change it to like a vertical tangential arc, or I can just do a tangential line for both of them and give it an extension distance in here.
So I'm sorry, I meant more like, let's say once you compute a toolpath, but you just want to delete one line from the toolpath. Like, let's say
You can use the graphical toolpath editor in here, and you can actually select a certain section of the toolpath motion. So for example, I can just go pick these sections in here on the toolpath editor, and I can go into selection edits, and there's an option you can do a cut. So that'll cut those selected motions.
Okay.
Or I could even do a graphical selection in here. So these are what's called graphical edits. So I can go to, let's say, a top view, and for example, I can I can select this path in here, and I can say select cuts by a rectangular pick in here. I can just drag a window to select the motions, so it highlights those toolpath motions in there, and I can do a cut, or I can do a move those selections into Z, or isolate those selections. I can do a cut, so that will basically, or you can even convert them to a Rhino curve. So right now it converted that particular toolpath into a curve in Rhino. So these are called graphical editing of the toolpath, and it's available part of the toolpath editor.
Amazing.
Okay.
Yeah. Another question. Can you create multiple work lanes? I'm sorry. Yeah, work lanes on a Rhino cam. So if you wanted to do like a 3+2 milling operation.
Absolutely. Let me do a 3+2 on this here. Let's say we want to just do a like a 2D profile cut on this, right? On this area.
Can I ask, while you're doing this, while you're demoing that, I have another question that maybe you can answer both at the same time.
Sure.
So flow line surfaces in the 3-axis, if you're surfacing using the flow line, can you select multiple surfaces in the same operation and then have it kind of calculate those simultaneously, or do you have to do a separate operation for each?
You can do them as long as it's in the same orientation. You can do multiple. So I can add a new setup in here. So, and then I can orient my setup to be, let me display here 1 second. So if you take a look, you can actually go ahead and rotate your coordinate system right there. You can tilt it to whatever angle you want it. You could even basically base it off, like in Rhino, one of the things you could do is you can put your C-plane in Rhino based on 3 points. You can say C-plane, you can rotate or use a 3-point pick, and I can say I want to put it based on, I can define my X-axis to go, along this one here. And then maybe pick this as my Y-axis in here. So you can see now the C-plane orientation is changed. So if you go into a setup, you can add a new 3+2 orientation, and you can say, to the active construction plane, and select OK. So now you see that the setup is now being rotated based on the new orientation. Or you can even use the controls in here to go back and rotate your setup by whatever angle you want it to. So for example, you can say you want to rotate it 15 degrees on the Y. So basically it lets you rotate the setup to any angle, any combination that you want to do. And once you've oriented the setup, you just program your toolpath. So I could say I want to do a 3-axis curve machining operation, or like a horizontal finishing. You can do any operation in 3-axis, and you can do multiple areas. So as long as you're in the same orientation you're trying to cut, you can do multiple of them. I could even do like a curve machining, or between curve machining. So I can do a curve machining in 3-axis, and I can just say I want to pick this curve. So the tool basically is going to be, in the orientation, you've already established that. You grab a tool for it. So let's say I want to go with a ball mill here, generate the path. So you can notice that now the orientation is locked in that position right there. So you could be cutting from multiple sides, multiple features using curve machining. It's not, you don't have to just do one in each. So you can also determine what the angles are by just selecting the setup. It shows the primary axis is tilting by 0.2 degrees, and then the secondary is going by 60 degrees. So we did some random orientation. So it'll compute the angle based on the machine definition that you define. So you can set your setup to be, the orientation to be normal to a surface, normal to a planar curve, to a construction plane, or you can do a combination of any of these to establish your 3+2 orientation. And you can apply any of your 2 and 3 axis operations when you're doing 3+2. And you'll have access to all of the advanced 3 axis operations too.
Got it. Another question, is there a way to detect, let's say, singularities, or let's say you're milling a sphere and then your axes are twining, intertwining. Is there a way to detect that before running the program on the mill? Like sometimes we will post-process a file, and then once you try to execute, you will get an error saying that you're either your toolpath is either going out of the limits of the table, or that there's some singularity being detected.
Okay. So we actually mark the when we post-process, we actually let you know if your output is outside of the limits in terms of the primary and the secondary axis angles. So when I do a post-all, if they're outside of the limits, it's going to actually display a pop-up in here and tell you that your machine angle limits have been violated. So it'll notify you, and also it'll mark those in your toolpath itself. So it'll mark in the toolpath editor itself. So in this particular file, you can see it starts at 1.9 and goes to 22 point something, right? So you can see the angle stays, between 80. So I can limit it here. Let me go back and say my limits are maybe like 0 to, let me change it to maybe 75, right? For example. And then I'm going to go back and regenerate this, and you will see that if it's outside of the limits, it's going to flag those motions in here. If they cannot reach those limits, it's going to flag, or it'll find an alternative solution for it to get to that position. But if it's still the computed angles are outside of the rotary axis limits, then it's going to flag and mark those in the toolpath editor, and it'll notify you when you're post-processing machine angles violated in the output. So in this case, it is still able to find it. So, and when you post, it'll notify you about it. Okay.
Got it. Yeah.
So you can establish that as well. So yeah, there are some checks that are built in. We do not set the limits for the work envelope, the X, Y, and Z, but we do for rotary axis limits. We do the check. Okay.
Great.
Any other questions on this particular part? And we can always help you make the changes to the post processor to have it output similar to what your current output is. We can certainly take a look and see what changes are needed, and we have a built-in post generator, so that's what we use to edit the post processor in here.
Can you just hover over the 5-axis operations again for a moment? I would just
Sure. We have a curve projection machining. This is like similar to an engraving where the curve projection, where the curve is actually projected to the model, and the tool will remain normal to the surface, but then it'll follow the curve. So for example, if I just go ahead and take a, let me just throw in a line geometry in here, or a curve geometry. So I'm going to go ahead and create a freeform curve, maybe start somewhere over here. You see I've created a curve right there, sir? I can do, I can either project the curve to the model, it's not necessary, but I can give it a projection distance for it. And you could say select this. You do a project in Rhino, select the curves to project. You can see Rhino did some sort of a projection. No, it didn't work, looks like. So I can put a curve on this. Let me simplify it here. Let me draw a curve. Just go to the top view here. And let me pull it up in the Z. I'll just put it up right there. It's some random height. So now if I do a 5-axis curve projection, and I go pick this curve to be projected, this one right here, I'll pick this surface. I can give it a projection, pick a tool for it, give it a projection height. I can say the projection distance, let me put in, I don't know how far it is, I'll just put in, 10. And when you generate the path, it's actually going to take that and then project it down to the underlying surface. So the normals are derived based from the surface, but then it'll use the curve to follow that. So that's a curve projection machining method. We have 5-axis flow curve. So the toolpath will basically, use a drive curve and then use a surface to flow along it. So I can do a flow curve, and I can select this here. I can pick this as my surface edge or a curve, and then pick this my surface right here. So the flow curve will be, okay, it looks like it gave an exception here because it probably, the minimum distance is too far out. Okay, so this one I can pick the surface and the flow curve, and you pick a tool for it. You can give it a step over distance. So that'll basically, the toolpath will use that and then, as a curve, but it'll flow along it. So basically the tool remains normal to the surface. So you have between two curve, you have surface parallel machining, Swarf. So that's a flow curve. All of these you can actually do it in the demo as well. You can't save or post the operations, but you can basically play with all of these. So if you have your Rhino Cam running as a registered copy or licensed copy, you just go up to your Rhino Cam and select the license. You release the license. When you close and restart the program, you can start it in a demo mode and choose the configuration as premium. So that'll let you evaluate, and you can play with all your files as well. What you can do is post it.
I'm sorry, can you go back? You said we have a demo mode?
Yeah, if you have the version 2019 installed, whether it's licensed copy or in demo, when you start a demo, you can choose the configuration to run as premium. But if it's licensed, you can release your license from the license dialog. There's a button that says release license to transfer to another machine. Once you hit the release button, you will be able to close and reopen the program, and then you can select run cam demo and then choose the configuration to run as the premium configuration.
I currently have RhinoCam 2018. Would I be able to do that with the 2018?
Absolutely. There's been more improvements to 19 in terms of 5-axis toolpaths and also in general in 5-axis as well. But you can do it in 18 also. Absolutely.
No, yeah, I was told that I couldn't before. So.
Yeah, so you just have to release the license and reactivate it, and then run it in demo and then pick run cam demo. Or if you have a second computer that has a copy of Rhino, or you can download a 90-day eval of Rhino and then install Rhino Cam 2019 and run it in demo. The only limitation on the demo is you cannot save the machining operations to a Rhino file and then post-process it out to your machine. But you can look at your, the CL file. It shows your cutter location. It shows all of the details in the CL file. So let me go back and program this curve machining in here. Maybe I'll snap to a few surface edges here. Okay, so now let me go back here and change the curve. We'll pick this. And then I'll just put in the distance as Okay, so now you notice here that the tool is actually being normal to that surface, but then it follows the curve. So that's your 5-axis curve projection machining.
Lovely.
And you got flow curve between two curves. It'll morph between two curves. Surface normal is like your similar to parallel finishing, which is parallel to the surface. You can choose a surface in here, and I can say select the surfaces. There's no curve required to be selected, and then I can specify the cut direction, the cut parameters. I can go parallel to X, parallel to Y, how you want the cut pattern. I can even do a combination of other, and you can do a combination. You can put in your step over, either as a % tool diameter or as a distance, and then generate. So this will create a surface parallel machining. So it basically maintains parallel to the Y in parallel lines, but then it's normal to the surface.
Interesting. I got a question. So is there maybe in the 3-axis, is there a similar to flow line, 5-axis, but an operation that would follow sort of the ISO curves of the surface?
Yeah, but we can do what is called a between curve machining. So let me show that to you here. So I'm going to go into Rhino. First, I'll do an indexed operation, right? So we'll do like a 3+2. I'll pick 3 point, and then I'll say I want to put my coordinate system. I'll just pick this to define my x-axis and this to define my y. Okay.
I'm sorry, that's not what I'm asking. What I'm wondering is, like, using the normal world coordinate system. If I had like a series of small different surfaces on a sheet that I was trying to cut, and I wanted to like kind of mass select all of these surfaces, but instead of just doing, sort of like parallel finishing on them, I wanted to mass select all these surfaces and then have them milled according to their ISO curves, like.
So if you'd like to do between two curve machining, then it has to be only two curves, and you got to program it. But there's other methods similar to that where you can use there's a method called flats machining where you can do an offset constant XY, a constant offset of the geometry. But for the ISO curves, then the best method is either curve machining or between two curves. So if you do curve machining,
individually.
Yeah, you can pick all the surfaces, and then you just have to pick the curves. You don't have to pick any surfaces in here. You just go pick curves. I can say I want to pick this curve right here, and then I can give it a, like if the width is the same, you can give it a cutting width in here. So for example, I could say I only want to cut on one side and give it a cutting bandwidth of, let's say, 3/4 of an inch. I'll pick a tool and then generate the path. So this is a normal 3-axis operation here. You can see it's in the machine coordinate system only.
Yeah.
And if I run a simulation, it's basically keeping the tool normal to the XY plane, but then following the surface.
Right.
So that's called curve machining or curve projection. These are part of the advanced 3-axis methods. It's available in our Pro configuration.
Right. We don't have that. And I'd have to do that for each surface individually, you're saying?
Well, you just have to pick the curve, so you don't have to do it for each surface here. I can go back and select multiples of these. I can say I want to pick this one. I want to pick this one. And maybe I can go pick something over here. It looks for the direction. So if the direction is on the wrong side, then it may not work on some of them here. You can see in this case, it's falling off this edge.
Right.
But in these two cases, it worked because they both are in the same direction. So you can actually create curves in Rhino and then make sure the directions are going in the same direction. So you can say duplicate edge. So if I pick these edges in here, and then I'll pick one of these in here too.
Is there a way to turn off the limit, that 3/4 of an inch that you set, so that it wouldn't just repeat the whole surface?
Yeah, if you wanted to do the whole surface, the curve machining, you have to give it a cutting bandwidth on the curve machining method. But if you do between two curves, then that would not be necessary. So if I do a 3-axis between two curve machining, and I pick these two, so that'll like morph between the two curves. You can give it a step over. All you have to do is step over in here. And let me just run it quickly on this one. Okay. So you can see it's flowing between the two.
Yeah, so now one more question about this. So I see that it's, you're using the two curves as the controls, but is it effectively just, is it even, is it using the surface or is it?
Yes, the two curves are like guiding with the path, but then it's basically checking against the surface geometry. If you notice the toolpath in here, it's not gouging.
If that was like a doubly curved surface and it was more free form between the
You see
curves.
right there, the tool is in contact right there with the surface.
Right on. Right.
Okay. So it's checking against. So yeah.
That's great.
Yeah, one of the things you can also do is you can set up like knowledge bases to do it, automate selection of curves. You can put them in layers and automate them by applying selection rules in 2 and 3 axis operations very effectively. The selection rules in 5 axis, wouldn't work well because you have to pick drive surfaces, wall surfaces, check surfaces. So the selection rules work very well in 2 and 3 axis operations. Are ideal for those applications. So with the premium, you also get the advanced 3-axis methods with the pro and premium configurations. So you can apply these even as 3+2. In this case, I just did it as a normal 3-axis. I can even do it as a 3+2 and it'll still work. So if I change the orientation and do it as a 3+2, all I have to do is regenerate the path. So I can go in here to Rhino and maybe change the orientation. I'm going to define the X to be along this path and Y to be on this path right here. So I changed it. I go back into the setup and say active construction plane. You'll see it flag these two operations as dirty. If I go back and regenerate it, now you can notice that the toolpaths are being regenerated based on the orientation of the coordinate system that we created.
Great.
Sorry, another quick question. It's not related to this specifically, but is there a way to work or make like a automated process, like a macro, where you have a toolpath, and I don't know, I'm thinking about maybe assigning a layer to that toolpath so it would always pull the surface from a specific layer?
We do that in 2 and 3 axis operations. We call them as selection rules, where we can do curve selection. So for example, if you want to do like a curve machining operation in here, so I'm going to take this, I'll put this into a knowledge base here. And let me go ahead and I can create these curves.
Hey, Michael, Sobeto wants me to...
Okay, I'll put in layer 2. I'll put these objects in here, change object layer. Okay. So what I can do here is use the selection rules, and I can apply it, say, for the curve machining, I can select, say, apply selection rule, and automatically pick geometry type, or I can use a layer filter, or I can say color filter. So I could say use a color filter, I'll put layer 2. I'll do the same for the between curve also, or I can pick a different layer. In this example, I'll just use the same layer name for both. So I'll apply selection rules in here. I'll save this operation to the knowledge base with the rule on it. So now when I load the knowledge base, I'll load the knowledge base in here. I load this one. You'll notice that when I pick the operation, it automatically picked the curves that are on that layer.
Right.
So this can work with curve selections in 2 and 3 axis operations, the selection rules. Like I said, they wouldn't, be applicable to 5 axis operations because you need to have surface selections as well. But you can make your workflow simplify in Rhino. One of the ways you can do it is you can go into, let's say, curve projection machining, and you can apply for surface selection. So you can select surfaces. You can right-click on a layer and say select objects.
Right.
In Rhino. So it'll add all of the surfaces. So that way, it makes your selection. It simplifies your selection.
Okay. Yeah, I'm just thinking we have this field, maybe like this model that we're looking at, but it's maybe 50 different geometries.
Mm-hmm.
I'm just thinking of ways where we can automate that process.
Okay. Yeah,
Because
so you can use some, you can probably structure it in Rhino so they're all in the same layer. And then you can even, just make that layer visible and drag a window to select all of them when the selection dialog is invoked. Or you can right click on the layer and say select objects.
Right. Okay. And yeah, I guess, I don't know. Yeah, I don't have any other questions. I'm sure that once we start, browsing through the interface and all that, we'll have more questions. But,
Okay.
I think I'm good. Michael should be back here in no time. But
Okay. So I did look at the output that you guys had sent us here. So looks pretty standard to me. There's a few things we can add, like these. We can add these into the post, like a program startup code. And then if you're doing a G48S1, we can put it in, or it's called, if they're calling it just an RTCP on, we can add that in, say, instead of G48S1. So I believe the 8065 uses G48S1. We can enable that, and then everything else you can see it's pretty much like B and C here. Looks like there's some indexed operations going on in here. And then you have some continuous operations as well. So the output looks very similar. And we can edit the post processor to output something similar to that.